Welcome to Unit 4, Lesson 2, the remainder theorem. Now that we know what a polynomial looks like, we're going to learn how to do long division with it. So, polynomials are functions that are made up of factors, and typically those factors look something like this: x plus 4, x plus 3. And we're going to learn how to find those factors today from a given polynomial function. This may have you shaken in your boots if you don't remember long division, but basically we have some terms here that we need to understand and then just apply them to the polynomials once we start dividing them. So the dividend is 327, this one. The divisor, the thing you're dividing by, is 12. So remember, this question is asking how many times does 12 go into 327? The quotient is the answer, and then the remainder is 3. We can do the exact same thing with polynomial functions. Here, the dividend is the thing that's getting divided. It's underneath the division symbol. The divisor is x plus 3. The quotient is x plus 4. Notice these are two of the factors of this function. And then our remainder is plus 5. Now, when we divide a polynomial, we get a resulting, it's in this format: p of x over x minus a is equal to q of x plus r over x minus a, where q is the quotient, so whatever your result is from the division, and r is the remainder divided by x minus a. So check the division of a polynomial by multiplying the quotient, q of x, by the binomial divisor, x minus a, and adding the remainder. The result should be equivalent to this function here. So that's how you can go back and check and make sure that what you put in is exactly the same as what you got out. There's an example here. Divide the polynomial p of x is equal to 5x cubed plus 10x minus 13x squared minus 9 by x minus 2. I put a note here: write the polynomial in order of descending powers. So whatever the exponent is, they need to be in order from biggest to smallest. This is a sneaky trick that you would see on assessments to try and catch you up and make you make a mistake. So just be conscious of that. Take the second and write it out from biggest to smallest. It will save you a lot of heartache in the end. So what we're going to do this one by long division, and then so that we understand the process, and then we're going to learn some shortcuts from there. So we have x minus 2 as our divisor, and it's going to be going into the dividend. So here's how you do it. We go x into 5x cubed. It goes 5x squared times, because what you're going to do, if you remember from long division, is you're going to take this number and multiply it by the factor over here that you divided by to give you this new number. Of course, we're wanting that first number to cancel out. So 5x cubed, 5x squared times x gives us 5x cubed. And then how did we get this negative 10x squared? Well, what you're going to be doing is taking think of this in terms of, we're going 5x squared times x minus 2. So using the distributive property, we would multiply 5x squared by each thing in the brackets, and that's where this 10x squared comes from. So the second step is 5x squared minus 2 times minus 2. That gives us negative 10x squared. This minus this is, of course, 0, so we're done with that term. And then you're subtracting here. So if you're wondering, why is that negative when we have minus minus, it's negative 13x squared minus negative 10x squared, which of course is the same as adding 10, or minus 3x squared. Once you get to this point, we're going to go back over here to our x and see how many times does this go into negative 3x squared. So the negative sign goes there. Of course, this goes in 3x times x to give us 3x squared again. And then negative 3x times negative 2 gives us positive 6x. The 10x is, of course, just dropped down. If you don't remember how to long divide, just go online on YouTube and watch a long division video just to refresh your mind. But I'll show you some shortcuts using the synthetic and remainder theorem that can get you around it if you're not good at this skill. Be cautious of the fact, though, that you may be asked to solve a problem in this format. So anyway, you just continue on until you run out of factors. x into 4x, of course, goes 4 times. 4 times x gives us 4x, and then 4 times negative 2 gives us negative 8. And we're subtracting it again, so here we have a remainder of minus 1. Once we have that, we can say this polynomial divided by x minus 2 gives us a resulting function of 5x squared minus 3x plus 4 plus, and then here's our remainder over our divisor, negative 1 over x minus 2, negative 1 over x minus 2. Because of course that won't give us a perfect function, perfect result. So we would want to just reflect that in our answer. Now keep in mind we cannot divide by 0, so x cannot equal 2 in this circumstance. To check, you just plug it back in and confirm that the two sides are equal to each other. That's the basic idea behind it, but we have synthetic division as a shortcut. So this can be a way to take the confusion out of it and help you to find the answer a little bit more quickly. So for example, divide the polynomial 2x cubed plus 2x squared minus 4x plus 15 by x plus 3. So here's the steps. Write the terms of the dividend in order of descending power. I'll just underline descending for you again so that it draws your attention to it. So make sure we're going from biggest down to smallest, which we already are in this circumstance. Use 0 for the coefficient of any missing powers. So for example, if we didn't have the 4x there, if it was just 2x squared plus 15, we would insert a 0x here just to reflect that there is that place held. And you'll see why in your practice examples later that is very important. Once we've done that, what you're going to do is just write the coefficients of the dividend. So we're just taking the 2 from here, the 3, the negative 4, and the 15. And to the left, write the value of plus 3 from the factor x plus 3. And then below plus 3, place a negative symbol to represent subtraction and make a horizontal line, kind of like an equal sign, and then a multiply symbol down there. So that's how you set the problem up. Once you're at this step, then you will do the following things. Step number 1, you're just going to drop down this 2 to give us our first thing to work with. And then you will multiply positive 3 by 2 to get 6. And that answer goes here. Okay. Now that you've written the 6 there, you're going to subtract 6 from 3. That will give us our negative 3. Multiply by positive 3 up here. Multiply by positive 3. That gives us negative 9. Negative 4 minus negative 9 gives us positive 5. 5 times 3 gives us 15. 15 minus 15 gives us 0. That also tells you that x plus 3 is a factor of this function. So once you've done that, then you can rewrite these corresponding values with their appropriate x terms. So we get 2x squared minus 3x plus 5. Don't forget that x cannot equal negative 3 because x plus 3 can't equal 0. We can't divide by 0. So you can check by long division and see what is the final function for that. This is a really good way to confirm your answer and check and make sure that you did it properly. Now, you can also get some application questions. So you might be given, for example, in this question, the volume of a cube is expressed by this polynomial function. What are the possible dimensions of the box? So we know that h is one of the factors. H equals x plus 1 is one of the factors of this polynomial. And this question is basically asking you, what are the factors L representing the length and width, L and W? Set up you can do it by long division or you can do it by synthetic division. It's completely up to you. But when you get to the end of it, you get this polynomial x squared plus 6x plus 6x, x squared plus 6x plus 8. And you can factor this one out into x plus 2, x plus 4. So that tells us that the dimensions of our cube that was given. I don't know which one's the length or which one's the height. That doesn't really matter. But you will get x plus 4 and x plus 2 as your dimensions to solve this problem. A second shortcut way that you can use, I think the synthetic division is the quickest and easiest way to do this type of problem, but you can also use the remainder theorem. So you can kind of just find the one that works for you and use it, but you do need to know how to do all three. So the remainder theorem states when a polynomial in x, p of x, is divided by a binomial in the form of x minus a, the remainder is p of a, i.e., fill the value of a into the formula to find the remainder. So if the question is just asking you for the remainder, do this way so that you save a lot of time. In our example, we have p is equal to x cubed minus 10x plus 6 and is divided by x plus 4. So since the binomial is x plus 4, then x equals x minus negative 4, and therefore we're going to be evaluating p of negative 4. So you just take that negative 4 value, plug it in. Anywhere there's an x, put a negative 4 and just solve for it. When we get to the end of this question, we find that the remainder is negative 18. Now what you can do is use synthetic division to solve this as well, and you should get the same answer no matter which method you do, and you can also use this as a check for each other. So using the synthetic division, you of course drop the 1 down, multiply, subtract, multiply, subtract, multiply, subtract, and we get that exact same remainder of negative 18.